Hello everybody, this is Introduction to Electrical and Electronic Engineering course. This is lecture 4 by Mr. Amr Abdelbari, Department of Electrical and Electronic Engineering, nearest university. Last week we speak about the resistance of the electrical circuit, and this week we will talk about the Ohm's law as it's the dominant law in the electrical circuit, and it's very easy. Remembering that the voltage have the abbreviation V and we measure it in volts, and current we have the abbreviation I and we measure it in amperes, and resistors have the abbreviation R and we measure it in ohm. Okay, as you see the relation between the current and the resistance in the circuit. As you remember, there is a relation between I and V. We measure it as conductance, and it is the inverse of the resistance. So V equal IR, or if you take the I from outside, then I equal V over R, or if you take the R from outside, the resistance, then it will be V over I. This meaning that the I, the current, is related to the inverse of the resistance value, okay? And the voltage is have the relation of the proportional direct relation with R, okay? So this is a very important law in electrical engineering. So if I have two information, I can get the other one. So for example, if I have the V, I can get the I. If I can get the V, if I don't, this is unknown for me. Sorry, if it's unknown for me, the V, I can get it by multiplying I by R. If I don't have, for example, the I just you see this circuit. I just cover this and divide V over R. This is an easy way of solving, okay? So you will be given two quantities and you have to solve it for the other one. I think it is very easy relationship, okay? Then the last one is for the R, the resistance, and you just divide the V over R to get the resistance, okay? Now, if you have an example, if I have a flashlight that's used a 6 voltage battery and the bulb have a resistance of 150 ohms, so what is the current? So as we remember from the equation, we just cover the current and then we have V over R, 6 over 150, which is 0.04. As you remember from the last picture of the last lecture, there is the quantities and units. So this can be a milli. This can be converted to milliampere, 40 milliampere. Okay. Now this is the man who expressed this equation, and we take it over his name, the Ohm, Simon, George Simon Ohm. Okay. So again, V equal I multiplied by R, or I equal V over R, or R equal V over I. That is the Ohm's law. Okay. Now, if you look on and remember from the electronic schematics and the models for the circuits, this is the circuit that we have in real life. This is the circuit, battery and resistor. But to explain it in papers and in schematic to work with a circuit, we have to use symbols that is standard for us to refer to the battery. So this is symbols. We use it everywhere and to solve the quantities, and to use it as like we have a symbols for the voltage and the current. We have symbols actually for the components of the circuit. Okay, so you remember this symbol for the resistance, and this is the symbol for the battery as a large or the dash, this line, and then a small line. This is referred to the minus and this is referred to the positive. Okay, so this side is the minus or the negative side, and this is the positive side. Now there is other symbols for other components. We will not cover this component in this course, but you know that there is something called transistors, have such things, diodes, capacitors. So we actually work in the circuits with this schematic, but in the real world, if you want to implement the circuit that you have, calculate everything for it, and it's actually working in theoretically, then you will use the real components. Okay, now this is another example. If you have a flow of 12 ampere and it through a 1 ohm resistor, what is the voltage? This is very easy equation. V equal IR, then it's 12 multiplied by 1, so V equal 12 volts. Another example, here he demand ask for the I, which is the current. So you have 12 volt in battery, and 1 ampere ohm, sorry. Then the I, V equal IR, or I equal V over R. Then 12 over 1, it is 12 ampere. Now another one, there they have 10 in battery and 5 ampere. What is the resistance? As the resistance V over I, then it is 10 over 5, then R equal 2 ohms. Okay, this is very easy. Now to the second part in this chapter or this lecture is the electrical power. Usually, as I said before, the amount of current and voltage within the system is related to the power. The power is measured in watts. So the voltage push some power, push some pressure in the circuit, and so this is have some energy inside. So the power equal to I multiplied by V. I is the current and V is the voltage, so I multiplied by V is the power. Okay, and it's measured in watts. I think you hear about this amount. Okay, now as you remember, the voltage is some energy. Okay, so it is joules per coulombs, joules energy per coulombs, charge. Okay, so we can relate the voltage and the current to the power. So before that, you said we speak about this subject, that the energy supplied by the element and to one direction is the other direction, just like absorption of the energy. Okay, so the charge carry the energy through the elements of the components of the circuit, and this component absorb some energy. So for example, the voltage that come across this resistance, you have VA from A to B, the plus here to the minus here, or V from B to A, from plus to minus. So take caution when you measure or make some symbols around the circuit, that the current flow is important, because it's make some hints about what is the direction where to measure the voltage. Okay, because this is negative to this one. Okay, now this is the positive reference for V. So power and energy, what is, we speak about two things, power and energy. Actually, power is equal to the voltage multiplied by the current. T here is the time, so over time. So to calculate the energy from the power, we will take the integration. The integration that you take it in calculus or linear algebra. So you will take over some time running the circuit in over the time, so over some time from T1 to T2. So the integration of the power, the delta T, it is the energy that's observed or transferred in this period. Okay. Now, as you see before, that's B equal VI. So if I have this circuit, for example, so V equal 12 and the current is 2. So the current is come from plus to minus. Okay. So the voltage is here. So what is the power? It's 12 multiplied by 2. Here it is in the P, it is here from coming from outside, so this is to the second side, and here for C, I equal minus 3, it's come from this side. Okay, so here the example to make it more clear, how much current flow in the filament of a 300 watt bulb connected to the 120 volt power line. So B equal IV, so I equal B over V, 300 over 120. This is 2.5 ampere. So remember to write the quantities for each each calculation, so you know that the current is measured in ampere, and if it is, you can make it higher up or lower down, so you can make it, write it in milliampere or kilo watt, for example. That's that's why you should write the quantities. Okay, now, or the units. How much the current? Another example, 60 watt, 120. It's just you divide the voltage, the power over the voltage to get the current, or 500 milliampere. Okay. Now there is this formula, P equals V multiplied by I. If you take the V from the Ohm's law equal IR, so you just do it here. It's I square R, or it's V multiplied by I. So you remove I and just V over R, so it's V square over R. So different shape of the two equation, the Ohm's law and the power formula. So you can just, if you have two quantity, you can get the other two very easily. Okay, this is the different writing for it, the same meaning. Okay, same two formula. Calculate the power in a circuit where the source is 100 volt and it produces 2 ampere, and resistance which is measured in 50 ohm. Okay, so he wants the power. Now I have the voltage, I have the ampere, I have the resistance. I can just put right I square R, so 2 multiplied by 2 multiplied by 50, it's just 4 by 50, it is 200 watt. Okay, another example, 24 ohm and dissipated 600 watt. What is the current? So as you remember, B equal IR. Okay, here B equal VI or I square R. So I will get I square equal to B over R. So I equal to, here, which one? Here. R equal B over I2 I square. So it will be I equal to the square root of B over R. So here the square root over B over R, it is 600 over 24, so it is 25. The square root of 25 is 5 ampere. So this is the last example for this week. Thank you very much for listening.